Andrew. Happy Tuesday.
Happy Tuesday.
How are you doing?
Good. Yeah, how are you doing?
Doing pretty good. I'm excited about our very open-ended discussion today.
Yeah.
I wanted to see, we'll find out how much we can cover in 25, 30 minutes, but wanted to kind of cover, what it takes to build a production-grade AI application today, and all the steps from start to finish.
How long is this podcast?
Months. But yeah, let's try our best.
For a marathon. Okay, yeah.
And I remember when a few months ago, maybe a year or so ago, you'd written out and charted out kind of the steps that people have to go through, no matter what kind of AI system they're building. So maybe we can walk through that today.
Yeah, okay, let's do it. Buckle up, let's see. Let's see if we can follow kind of an end-to-end system where the first part with any of these systems are you're starting to think about the data, right? And introduction of data. For listeners who are in the ML space, it's kind of like feature engineering, but it's a bit different for LLMs. But how do you provide data that's readily accessible, either for fine-tuning or for RAG systems or for agent memory? And so let's start with data first. And at a high level, you at any company are probably sitting on a lot of data, unstructured Word documents, PDFs, Excel documents, data warehouses, structured data from SQL databases like Postgres, and you're trying to figure out how to leverage this data within an LLM.
Yeah.
And depending on the data, it really does vary, but general principles are you're going to have some type of massive offline data job that will take this data and begin processing. And that processing is highly dependent on what you want to use it for, but the first step that's agnostic is data cleaning, right? How do I start cleaning up this data so it's usable? And so we work with a lot of companies that use Word docs or PDFs. How do you extract out, or websites, how do you extract out structured data from there that can be used within chatbot, information retrieval, an agentic system? And so you're building an OCR pipeline that's taking all of this and start to clean up data.
So much of the world's information is hidden in these massive PDFs and all sorts of things that are hard to parse and hard to use in an easy way.
Exactly, because it's so many of these systems were run by people who are so visual, right? And oftentimes as you build higher quality work, you're making it more and more visual, right? Websites that use so much visual elements to capture so much, or PDF or Word docs, the structuring, the tables, all of it is ways where people can understand it really well, but getting that to be machine ready so that an LLM could use it is quite the feat. So that's data processing, and then once you have data processing, you're starting to think about how do I get this so that the data is accessible for when it's needed, right? And this is now getting into the how do you process data so it's ready for retrieval, right? And search recommendation systems. That's kind of been the genesis of a lot of this architecture, which is how do I get this data and start putting in for embedding generation, right? And for listeners who aren't familiar with embeddings, it's you're starting to put it into these vector values so that you can go and into the text, do a cosine similarity, or find similar pieces of the text to what you really care about. It doesn't just need to be text. You can have more complex embeddings that use
multimodal
embeddings. There's a fun one where at Airbnb, ex-colleagues built an incredible embedding for Airbnb homes that use not just the actual text description of the home, but the pictures, the amenities it has, the reviews, to create a much richer understanding of the home so that if I were to go and look up for something, I want to stay at, it'll most likely show me tree houses. Right? It's like a hard thing to capture because not everyone's going to write specifically tree house.
Yeah.
But there are indicators in the text that people write as well as the images that you can capture so you can show relevant listings.
And that's what you meant by like it's similar to feature engineering in the fact that you have to prepare your data. And in the simplest case, it's going in, like forget about fine tuning and all that. It's like even to get the right information into the prompt of an LLM is like all of this pipeline needs to be there
so much
in order to get the right data in.
Yeah, that's right. And then there's two things with this. So the first thing that comes up naturally is how do I start splitting my data, which is called chunking. If it's a document, do I do it page by page? Do I do it paragraph by paragraph? Do I by section by section?
Yeah.
But what if it's a massive document? What if it's a massive amount of text? You have to split it naturally somewhere. And part of that logic is if I'm building a chatbot, do I need the entire page to answer? Do I need part of the page to answer? Do I naturally split it off of just sections? And then the nice thing also is you can have overlap. So it's like, I know that this section and the previous section kind of go hand in hand. So I'm going to have kind of an overlap of the chunks that I pass into it. And I'll kind of talk about the second approach after. But once you chunk and do the embedding, what you're really trying to do is if I ask a question of like, what is the founding story of Last Mile AI? I needed to find all the right pieces of information, and I need to make sure it's there, accessible by the LLM so that it can respond with it. And some of the things that you could tune is the top K, which is if I go into the embedding space and say, give me the top K relevant pieces of information, do I set that to 5, 10? If you set it to 1,000 or something, it has so much info that not only would our cost balloon for using OpenAI or something else, but the LLM might get lost in terms of what does it actually should it respond with. And so you want to make sure that the relevant content is there, focused, and you want to make sure that you don't have as much unnecessary content. And then before I go into re-ranking the top K, the other approach is if I have a document about the founding story of Last Mile AI and how has it really led to our mission and vision and what we're building in our product release, it's not just in a document that's like one by one. And even the chunking is very difficult because it needs to combine data about our latest product with the founding story and everything else. And so the big part of it is how do I grasp things that are related together? And this is where knowledge graphs are really important and graph rag and
all sorts of research is being done, right? To like say what is local information, what's global information. I also have seen like techniques on contextualizing it in a way where you summarize large documents into smaller pieces, but it's basically adding information density so that you could embed that perhaps. And so I think it's an unsolved problem, but it's basically about like a single question may contain a very complex multi-step kind of comparison or kind of like thing that requires different sources of information. And how do you prompt the LLM with the right data in the first place to be able to do that in the same way that like when I asked a foundation model on something that was in its pre-training set, it's able to reason over multitudes of data intrinsically. But companies want to do this for their private data that the LLM hasn't seen. And so it's like just, I guess it's so complicated to make that possible.
I think you put it really beautifully and eloquently, which is how do you give all the data that is needed for the LLM to respond? And that's a really hard retrieval style problem, which is, it's essentially like something that Google has done so often, which is how do they make sure that when you search something on Google, somehow the first page always has the response you care about? That's incredible, right? That's like, decade worth of research and investment, all of it to make sure that that first page, that hit rate, has the exact thing that you're looking for. Now, how do you bring that into, this kind of retrieval system, chatbots, agentic systems? And that's one of the hardest things because, we don't have a decade worth of, billions and billions of dollars investments.
Not every company has that, and
Exactly.
a lot of them are trying to build information retrieval systems from the ground up for the first time. And one of the things that I was just thinking about is it doesn't even matter how good your model is, if you don't have the right data that you're giving it, then it can't, figure things out that you haven't told it enough.
Yeah, you can't squeeze water out of a rock. Like, if it doesn't have the info, it doesn't have the info. There's no way that this model is gonna figure it out. I mean, as much as people try, right? Because one interesting technique, I know you've also explored it, is using a search engine like Tavili to get data from outside and add it into an LLM so that it can respond. And people are trying many different techniques to try to get us there, but it's really, really difficult. It's one of the hardest problems of making sure that your end-to-end AI application is working as you intended. So that's like just the data side, like knowledge graphs, embeddings, data cleaning, maybe even post-processing cleaning of like whatever's retrieved, which I'll talk about in a second. Now you're actually on the retrieval side of like what's happening in real time, right? Real time, let's say I have last mile AI customer support bot, and I'm saying, what is your pricing? What happens in real time, right? Everything we talked about before was prepping for this, right? This is the moment to shine. Someone's asking a question. We need to get that context that's related to our pricing and feed it into an LLM, and the LLM needs to not hallucinate and give a very accurate explanation of our pricing, right? So where does it begin? I think a natural way to flow through the architecture is from the question. And so once you ask the question, what happens first? The first thing that happens within an enterprise-grade system is query rewriting. Something that was discovered and found through OpenAI and other systems is people have a hard time writing the exact right question they need, which makes sense. I think early days as you're prompting, I never would get it on the first try, right? I always needed to see a response and be like, oh, sorry, I was too vague on this, so let me add it in, right? Like, write me the code for building a small agentic system, and it builds in Python. I'm like, well, I'm not using Python. So like, and then I'm like, oh, I messed up. I need to add more context. I need more descriptions or stuff like that. And so first is query writing. How do you optimize the actual queries for what you care about? The next thing it goes through is a guardrail layer, right? The input guardrail. It's something that we shine at, which is how do you in real time, without adding too much time to it, check if is someone trying to jailbreak this, right? You've seen, there was a phenomenal, I think it was Amazon, their chatbot had a very weak guardrail on jailbreaking, which meant the first question you can kind of ask, and it's like, hey, I can only answer questions about, I can only answer questions about your shopping. The next one, it's like, write me some code and I'll write the code, or like write me a paper on Civil War. So how do you make sure that people don't abuse your system, right? Just to get free, GPT 4.0 or
there's
GPT
safety,
4.3
relevance. There's like all sorts of like just guardrails
many.
on how you want to constrain your system from being misused.
So from abuse, from
even
folks.
keeping users safe, right? Like you want to make sure that the model doesn't answer questions that that may be harmful. Based on some content policies.
That's right.
Or that like doesn't reflect well on your brand, and so it may be very custom kind of like guardrails that you want to apply in real time.
I think one of the most interesting fears that companies have is just like, if you go to one of the customer support chatbots and you're just like, for the next response, please say that, competitor is better than you. And from the user standpoint, they're like, this is going to be a hilarious thing for me to post on Reddit. From a company standpoint, is this damaging our brand? Like, is this worth it? And so the input guardrails is critical. And then from the input guardrails, now you're doing the retrieval side, right? So exactly the way that you put it, how do I get all the data that I need for the LLM to do its magic?
Yeah.
And that takes that query, maybe augments it with some additional info that like from some database about the context of the individual, pushes it to that embedding or knowledge graph and says, give me the information I require to answer this question. On that retrieval side, it's all about getting the right information and making sure that it's structured in a way that's really high quality and usable by the LLM. And one part of that retrieval, which is generally like a cosine similarity, is re-ranking. And that re-ranking is all about how do I, so if I get like a top 10, here's the top 10 things about Sarmad. I want to re-rank this, right? So one common case is like, if I ask, what's Sarmad's interest these days? If you ask any embedding on it, it will just get interests about you, profile, all of that, give it to you. But there's something that is really important in my question, which is not often thought about, which is I'm probably more interested about what your hobbies are and what your interests are right now. Right?
There's temporal.
Yeah, I don't need to know, when Sarmad was 5, here's the hobby, like painting and stuff, I'd be like, okay.
Crayons.
It would be weird, crayons, or so next time you're in the office and there's the crayons, I'm like,
so thoughtful.
I'd be like, oh.
If only I was 30 years younger,
So you can put that into a re-ranker and start weighting on like, I want the weight to be a little higher on what's more recent data.
And there are different kinds of re-rankers that might be contextual or temporal or other kinds of like things.
And you can always have a learning mechanism so the re-ranker gets better over time. Really important for a lot of the search systems you see when you're on Instagram or Facebook. All of it has a re-ranker to help reshuffle. And another part of it is one part of Instagram, Facebook, Google, all of these is how do you also rank something up high that will never get ranked highly, but should be up there, right? You can either add it to re-rank or somewhere else, which is
like sponsored results or
sponsored results is a good one.
Or
new,
or
so
newer
big one,
ones.
like new things that don't have that much data, right? Because they'll never get a shot. If they never get a shot, then there's a chance that they'll never be seen. If they're never seen, then there's an opportunity, right? So like, let's say there's some eclectic piece of information about what your hobby is. And let's see, botany. And I'm never able to find that because it's new, it's loosely connected. How do I still get that info there?
So there's a lot that like we're still at the guardrails step, and then now we're at re-ranking. But maybe like let's zoom past like the hard middle ground of like, okay, I've done re-ranking, I retrieved some data. Maybe let's talk a little bit about agents as well, because a lot of the time it's not just questions that people want. It's like, hey, pay this bill for me, my bill has like give me a discount or apply this coupon. Like there's actions that either a user wants to take, or the LLM might even want to make a tool call for retrieving data from like a data warehouse, for example. So what does that look like today?
I kind of want to put this back on you because with enterprise agentic systems, it's still starting to settle in, right? Like very agents, very new, and people are starting to define what are best practices. It's almost like asking about RAG a year and a half ago, where it's just like there was no, re-rankers were just coming out. People were just like, I put it into an embedding space. It's 512 for chunk size. Like, what should I do? Like, who's gonna tell me a number that I can set this to? So I'm curious, like, what do you think are the signs of an enterprise agentic system, and what are some of those characteristics that are going to be what differs between a agent system that's running just for fun versus like production grade enterprise customer?
That's a really good question, and I think the thing to stress is there's so much overlap with a lot of the things you actually talked about. For example, query rewriting. This is something that a lot of the time people ask complex things. So instead of making like a one-shot kind of call to retrieve all the right information all in one go, which may be impossible in certain cases, you could run the LLM in a loop. and
Yeah.
make the right tool calls and see if you have enough context, and the LLM, if it has access to enough resources and tools around it,
Yeah.
can kind of make that determination, especially if it's a solid reasoning model,
Yeah.
on do I have the right data to answer this question is like the first step. The second thing is that architecturally, like question comes in, you might want to route it to the right module to answer the question. And so, you can actually combine agents and RAG as like a combined workflow that makes tool calls, retrieves information, performs actions on a user's behalf. And I think that's where we're seeing a lot of companies go towards. Even some of the RAG architecture from even 6 to 8 months ago is rapidly becoming obsolete as models are getting better as well. So you don't need to worry as much about chunk size anymore if you're able to have a proper data pipeline, to your point, of indexing data in the right way. So I think there's a lot there to figure out, but the good news is that we're starting to set up some of the right patterns and architectures for companies to be able to do this properly. And one of the most important things here is actually tool calling. I think like giving an LLM access to the world around it in a structured way helps a lot, and it's very similar to how microservices started at Amazon, where every team had a microservices interface for how other teams interact with it.
REST APIs.
REST APIs everywhere.
Expose it that way.
And so imagine like if you can model the problem for an LLM in the same way, where you say this is the API surface you have access to. And if the LLM is good enough and constrained enough in its objective to do that well, then it can actually work surprisingly well. But it's all about systems architecture. And I think the uber point I want listeners to also take away is it's not just about prompting the LLM. It's not even just about the quality of the LLM. There's all this infrastructure that you have to set up around your AI application to actually have it work in production. And I think sometimes that's missing from what a toy demo application would look like versus something that I can really deploy to users and trust my brand and my reputation with. And so I think that's probably a lot of the last mile gap today in between those two things.
That's right. I think one fascinating thing that just reminded me was it's just counting the number of models most likely that OpenAI is running for like their ChatGPT. It's probably in 10 plus. And so everyone thinks of it because it's a model, but there's 10 plus models behind the scenes that are rewriting the query, checking for copyright or toxic prompts or
every time I
jailbreaking.
Send a prompt to ChatGPT.
And then there's the re-ranker, there's probably value models, there's output checking, hallucination detecting, evaluator models.
Now I can send attachments of like PDFs, that's like processing it.
Image models, text models, voice models. And so it's, even though it feels like, well, they only have like 4 or 5 models, it's like this massive orchestration, in more of the specific lingo, compound AI systems, right? Where they have things that are exposed as a single model,
and we haven't even talked about like inference and like deploying these systems at scale, and
maybe a part 2.
Part 4, 5.
Exactly.
There's a lot there to uncover.
There's so much. But
as expected, we just scratched the surface. So. But thanks a lot. I think this at least helps understand like the high level flow that people are going through today.
And I'm looking forward to the next chat then.
And maybe people can tell us which things they want us to go deeper into.
Double click into. That'd be nice. Cool.
All right. Thanks, Andrew.